Okay, hello everyone. This video today is to show how you can write the error function in terms of an incomplete gamma function, which I find quite interesting. So as we all know, the Gaussian, not the Gaussian integral, but the integral of e to the negative x squared is equal to root pi over 2 of error function of x. But in this video, I will show you how this is actually equal to this integral over here, which I wrote, which is essentially equal to this upper bound incomplete gamma function, but I did it as a lower bound incomplete gamma function because I don't know, I just did the calculus that way. So apologies for that. So the main way that I'm showing this is that I can rewrite the integrand as the product rule of this answer over here, which is what I believe the integral to be. So if we use the quotient rule of this, you can do this yourselves. You get this monstrosity, and if you expand out all the brackets, this will essentially be simplified to e to the negative x squared. And yeah, therefore, this means that if the integral of e to the negative x squared is the same as taking the integral of this giant thing over here, that should be the integral that I propose because the quotient rule works out that way. So again, sorry, I just added this in because I just realized that the upper bound gamma function is a thing. So the thing I wrote up here, if we simplify all the x's, this will simplify to the upper bound, half of the upper bound gamma function of a half, with x squared as the upper limit. Now, again, we can turn e to the negative x squared into the quotient rule that I proposed above. We can add 0 by using the gamma function, dividing it by 2x, multiply the top and bottom by 4x squared, and then we rearrange again to get the quotient rule that I proposed. Now, if we look at Desmos, we can actually graph the error function and the integral that I proposed, and we can see that they line up perfectly. And if anything, the one that uses the gamma function or this integral is better because we know that the area under the curve for e to the negative x squared will never have any negative values. And this is actually a more pure way of showing the actual area under the curve. Then we can equate the two equations to each other, so we can say root over pi over 2 error function is equal to this upper bound gamma function. Now, obviously, we can't represent the error function using elementary functions, but this is just another fun way of showing how the error function can be equivalent to something else in terms of the gamma function, and what I find a better way of showing the area under the curve for e to the negative x squared. Hope you enjoyed the video.